Hi guys, today we're going to learn about quadratic function applications, more specifically about projectile motion. The two equations that we have for projectile motion problems are the following. H of t is going to be equal to negative 16t squared plus v sub 0 times t plus h sub 0, and this equation is going to be used when we have a situation that uses feet. If we have a situation where we are using meters, what we're going to do here is we are going to use the following equation. H of t is going to be equal to negative 4.9 times t squared plus v0 times t plus h sub 0. And this one we're going to use if we're talking about a situation where we're talking about meters. Okay, so the steps that we're going to do here, that we're going to follow to solve motion problems are the following. Step 1. You're going to write the equation of the height as a function of the time by substituting the velocity and the initial height in the correct formula, meaning these two are going to be numbers and these two, okay? So you're going to have one or the other. Step 2. You are going to sketch a graph and label, okay? You are going to use the calculator and adjust the window to find the intercepts and the vertex. After that, you're going to answer the questions. So let's look at this example that we have over here. An object is propelled vertically upward from the ground with an initial velocity of 20 meters per second. So the first thing that I recognize is if the object is vertically, propelled vertically upward from the ground, I know that the h sub 0 is going to be 0. Okay, and in this case we're talking about meters, so 0 meters. Another thing that is given to me is the initial velocity. The initial velocity, the v sub 0, is going to be 20 meters per second. Okay, so you have this too. The first thing that you need to do after that is you need to create your equation. Your equation in this situation is going to be h of t is going to be equal, and since we're talking about meters, we're going to use the negative 4.9, okay, t squared plus the 20 because you have the initial velocity times t plus 0, that I'm not going to write because I know that that's nothing, okay? You can write it, but it doesn't make any difference. The second thing that you're going to do is you're going to label your graph in this situation. I know that the height is going to be the representative of the y-axis, and the t is going to be the representative of the horizontal axis or the x-axis. I know that the time is in seconds and the height is in meters. Okay, so far we have this, and in this situation my object will start at 0, 0 because it starts from the ground. Okay, after that I'm going to use my calculator here. Okay, so let's go to calculate. Okay, so you can just start in calculate. Okay, so go to documents, file, new document. You don't want to save whatever you have. Okay, so you're going to graphs. Okay, add graph. Okay, and here we are going to plug your equation. In this situation we have the negative. I always use this negative at the beginning of the equations. Negative 4.9 times x squared, and as you can see here I'm using x instead of t because the calculator is already built in with the x's, so might as well I take advantage and I put that in x's. Okay, so you have this, that it's exactly the equation that we just create. Okay, so I just hit enter and I have that. You know by the equation that it should be a parabola, but at this point I'm like, this doesn't look like a parabola. So what you need to do is you just need to zoom out. Okay, and the best way to zoom is menu. Okay, go to window zoom, and in window zoom the one that I like the most is the zoom fit. Why I like the zoom fit? Because the zoom fit will show you the overall behavior of your graph. In this situation it's very far away, so I can just go ahead and menu again and window zoom and zoom in so I can see the situation. I know that quadrant 1 is the one that I have in this problem because it's a real life situation. So you can see here, this is the object traveling across the air, right? Okay, so with that being said, let's answer the questions. Okay, when will the object be 15 meters above the ground? So you know that this is the height and this is the time, so I know when this is 15. Okay, so what I'm going to do is I press tab here. Okay, you click hit 15 here, hit enter, and you're going to have another line. So I know that in the intersection here and here is when the object after that time is going to be above 15 meters. Okay, so what you have here is you need to look for menu, okay, and analyze the graph, and then you look for the intersection, okay. You're going to have this, and with the mouse pad that you have here, you move that dashed line and you click here and here, and this is going to be your time. So after, I know that it's going to be after, okay, 0.99, and that's a 0 seconds, okay. So when will the object after that, and the other equation, you have another intersection here, so we need to repeat the same process. Menu, you are going to analyze the graph, again intersection, and then you use your mouse pad here, and then you're going to have another number, and you're going to tell me, hey, I don't see anything. Okay, so what you can do here is you use with your mouse, you have that little hand, grab it and then put it here so you can see it, okay. So you can see that value, the second value, is 3.091 seconds, okay. So that's your first question, okay. So the second question that we have, when will the item strike the ground? So you know that that's going to happen here and here, okay. So let me move the equations here because that's very busy, so I don't like it. Okay, so have that, okay. So what you can do here is you go to menu, okay, analyze graph, and you're going to find the 0, okay. First you need to select the blue one because that's the 0 that you want. So the 0 here that we want is over here, okay. So let me get here, analyze graph, the 0, I want the 0 of this one, okay. So it should be around here, okay. So that's the 0 that we want, okay. So you see it, okay. So at least we can see it even though your graph is super busy. Okay, so you know that one is going to be after 0.82 seconds, okay. So when will the object reach a height of 100? Will the object reach a height of 100 meters? Okay. So for that one, you need to make sure that what's the vertex, right? It seems that the vertex is not that high, okay. So, but you can always find it if you go to menu and then you go to analyze graph, and here you have a maximum, okay. So you select your blue graph, that's the one that you want to analyze, and you are going to have the same situation here. And let me grab the vertex here, so you can see that the vertex is 2.040 and then 20.408, okay. So I'm just going to record that that's my vertex because eventually I'm going to draw it here. So you know that the vertex is 2.041, 20.408, okay. So we know that that's your vertex, okay. So the answer would be no. Why? Because you know that 100 is greater than 20.408, so no, okay. Because the maximum height is what? Okay, you know that the maximum height is it was 20.408 meters, okay. And the last question is, what is the maximum height? The maximum height, we already know that it's 20.408 meters, okay. So with that we can graph everything here, okay. So the first thing that I know is that the other, basically 0 is going to be the point, what did we say that it was? It was 4.082, 0, okay. Another thing that you have is the vertex. You know that the vertex is here, so you have a situation like this, okay. Please note that the parabola continues, but we don't want that part of the parabola for our situation, okay. So those are the answers for your first problem. For the second problem that we have that a ball is thrown vertically upward from the top of the building, 96 feet tall, with an initial velocity of 80 feet per second. So the first thing that you recognize is they are giving you the height, okay, the initial height and the initial velocity. Another thing that you recognize is that they are talking about feet. So in this situation, you are going to have your equation h of t is going to be equal to negative 16t squared plus, and you have that it's going to be 80t plus 96. Okay, so after that, now that you have your equation, you are going to have that this is going to be again the height and this is going to be the time. The time again is in seconds, and then the height is in feet in this situation. After that, we're going to use our calculator to find after how many seconds of the ball strikes the ground, okay, and to see the overall situation that we have. Okay, so you go to calculate or wherever, doc, file, new documents. You don't want to save. After that, you're going to add graphs. Okay, once you add graphs, what you're going to do here is you're going to press this negative, okay, 16 times t squared, and then we have that it's plus 80 times x plus 96. So your situation looks like this, and you're going to be like, again, it's kind of crazy, I don't understand. Don't worry, menu, window zoom fit, so you can see the overall situation. Now, what is the part that we care about in this problem? This part that it's again in quadrant 1. Okay, it's a little bit far away, so what I recommend you to do again is to the window and zoom in maybe once or twice. Okay, click. That should be enough. If you want now, yeah, that should be enough. Okay, so after that, since we want to see when it strikes the ground, striking the ground means, you know, at 0. Okay, so we want the 0. So you go to menu, analyze graph, 0, and then you click here and then here, so you can see that that is striking the ground at 6. Okay, so pretty neat. You know that this is striking the ground, okay, after how many? 6 seconds. Okay, so you already know that it strikes the ground here at, let's say, 6,0. Okay, so after how many seconds will the ball pass the top of the building on its way down? So what is the situation here? Well, you know that you start, let's say that here's your 96. Okay, that's 0.96. Okay, so you have a situation that looks like this, right? Somehow like this. So basically they are asking you about this point. Okay, so what I'm going to do here, similarly to the previous problem, is I'm going to tab and I'm going to put when that it's 96, because that's the height that we're interested. Obviously it's happening here because I know that I start over there, but then it happens again here. So you go to menu and you're going to look for the intersection. You're going to analyze graph and you're going to seek for the intersection. You click here and you're going to find that your intersection, let's grab it with the little hand here. Okay, it's 5.96. Okay, so this point that you have here is 5.96, meaning that this is happening after 5 seconds. Okay, so what is the reasonable domain and range of the situation? And please remember that this exists, but we don't care about this part. Same here, we don't care about that part. Okay, so what's the reasonable domain and range? Your domain in this situation is going to be from 0 to 6. The domain, remember, it represents the time, so the present is at 0, okay, until 6. Okay, and the range is going to be what? The range is going to be from 0, okay, to 196. Why 196? Because the 196 is your vertex. Let me show you how to find it here. So you're going to analyze graph, maximum. Okay, you are going to click your blue line. Okay, and then you are going to select a range where you are touching the maximum. Okay, so you can see that it's 2.499,196, and you can just log it here, 2.499,196. Okay, and that's why we need also the vertex. Okay, And that's pretty much for number 2. For question number 3, we have that when a ball was thrown vertically upward, it was released 4 feet above the ground with an initial velocity of 75 feet per second. So you recognize that you are working with feet, okay, and they are asking when is the ball less than 30 feet above the ground. So the first thing that you are going to do, as usual, is you are going to create your equation. You have that it's going to be h of t is going to be equal to negative 16t squared, and then you recognize that 4 feet above the ground, that's going to be your initial height, and your initial velocity is 75 feet per second. Therefore you have plus 75t plus 4, and this is going to be your equation. Meaning when you go to your graph here, you know that this is going to be h, and h is going to be in feet, and t is going to be in seconds. After that, you do know that you are going to start at 4. Let's say that here is 4, so you know that this is going to be your 0.04. Okay, so you have a situation that it's going to be something like this. Okay, when of course this is going to be dashed. Okay, so let's basically dash this part. Okay, so because that's not part of your reasonable domain. Same here, you know that this is not going to be part of your reasonable domain. Now let's be more exact at labeling what we have. Okay, so let's plug this in your calculator. Okay, so you have doc, file, new document, you don't want to save, and then add graphs, and you're going to have negative 16 x squared, and then you have that it's going to be plus 75 times x plus 4. You graph your equation. After that, remember, we need to go to menu. You are going to Windows zoom fit. Okay, zoom fit is over here. You have the situation. Remember, this is the part that we care about. Okay, so we go to menu, you go to zoom in. Okay, because we want to see more about quadrant number 1. This is the part that we want. Okay, so what are we looking for? Since the question is when is the ball less than 30 feet above the ground, we want whenever it's 30 and below. Okay, so what you're going to have here is you press tab. Okay, once you press tab, this appears, so you're going to put 30. Okay, and you're going to look the intersections. As you can see, you have an intersection here and another intersection over here. So what we're going to do is we go to menu, analyze graph. You are going to find the intersection. Okay, so you have that dashed line, so remember to basically grab your point there. Okay, let me grab the point there. Okay, so you can see that that point is going to be this point that we have here, that is 0.376. Okay, so you do have that at 30, y equals 30. This is going to be your y equals 30. This point that we have over here, it's going to be the point 0.376, 30. Now we want to find this guy, okay, over here. Okay, so we also take our calculator, we go to menu, we analyze the graph, we are looking for the other intersection. Okay, that it's on this part. Okay, you're like, I cannot see it, don't worry. Make sure that you with the little hand you grab it, so you have that it's 4.310. Okay, so you have that it's 4.310, 30. Okay, so you know that basically the part that we want is when it's less than, so you want this chunk, and you also want this chunk over here. Okay, so we want this blue part that you have here and here. Okay, so please note something. Since it's less than, not equal, you don't want neither the point 0.376 nor the point 4.310. Okay, another thing, we also need to find the vertex. No, actually we don't need to find the vertex. The one that we need to find here is this point. Okay, we want this point because we know that the domain is from 0 to here and then from here to here. Okay, so we need this one. Okay, so you go ahead and go to menu, analyze graph, and I'm going to find the 0. Okay, so remember, when you have the 0, you need to select the blue graph, and then you select that, and you're like, where is it? Okay, remember that little hand is always helpful. So you have that it's 4.740. Okay, so this point is going to be the point, I'm just going to write it here, 4.740, okay? So you know that the interval that we want for this equation, okay, so summarizing, the ball, okay, is less, okay, than, what was it, 30 feet, okay, above the ground. Okay, at the interval, let's put the interval here. The interval that we want is from 0, we include the 0 because that's the present time, to 0.376. We don't include that one because at this point it's exactly 30. Union, and then we have this part that is going to be 4.310, okay, and then it's going to be up to 4.740, and yes, we do want that one because it's 0. It's when the height is 0. Okay, so you see it. And yeah, that's pretty much for this one. If you want to be more specific, this is in seconds, so you can say that it's in seconds. I hope that you find this video helpful. Bye!